Hi guys, I previously put up a video regarding the tide calculation in second reports. You can see the screenshot of this video here on your screen today. I'll also give you a link to that video. But I was told by one of the subscribers that the part that involved the interpolation was not very clear, and I kind of rushed through it. So I thought I'll make another video explaining the whole calculation to you guys, and especially focusing on how to interpolate the values when required in the proforma. Alright, so you can watch the previous video as well, as I'll give you the link to that video, but I'll show you the calculations from the beginning so that you guys can understand how I went about solving this question. So this video will explain the interpolation in the second report tide calculation. Alright, but I will show you the whole calculation anyway. So the question was that we had to find the height and times of the high water and low water for the second report of Enivitek atoll on 16th of October 1997. So for those of you who have not watched my previous videos, there are some ports which are secondary ports, which are smaller ports, and then there are standard ports which are bigger ports, and the values of tides, of height and times of tides, are interpolated in the same way for secondary ports as that of the standard ports, but they do not have to be closely located. But what we do is we use the height and times of the standard ports, and we interpolate some values and apply some corrections to derive the height and times of the secondary port tides. Alright, so let me show you how to go about doing that. So please again watch my previous video as well, and I have shown you extracts of tide tables that can be used to get the values. Here I have written everything down. So here are the extracts from the Admiralty tide tables, or ATT, that you can use to solve this question. So this is the first extract, which shows you the standard port of Davao. So this is the standard port, and standard port, which is like the bigger port for which the values will be given in Admiralty tide tables. The tide tables cannot include all the ports in the world, otherwise it becomes it will become a very big book, or it will become very difficult for mariners to use. So that's why they have referred to a standard port for many of these secondary ports. So this is the standard port, and here is the secondary port. They both have a number allotted to them. Alright, so the secondary port is Enivitek atoll. So this is the first extract that we'll be using, and the second extract that I'll be using is the seasonal change extract, and the seasonal change is given for monthly, and I'll show you what that means as well in the calculation later on. So the seasonal change for the month of October for the ports with numbers 6766 to 6788, and therefore Enivitek atoll with 6787 will lie here as well, is given here as 0.1. The third extract that we use is for the standard port. So the Admiralty tide tables has provided the height and times for the tides for the standard port, and the standard port here, as I told you before, is Davao. So for Davao, for 16th of October, it's given monthly and daily basis as well. This is the extract from the Admiralty tide tables, ATT. So these are the three extracts I'll be using to fill the proforma for my calculation, or for the tide calculation for secondary port. So again, the proforma for the tide calculation can be used for any secondary port. If you follow what I have done, you can do it for any other secondary port. So this is for secondary ports only, using the standard port as the reference. Alright, so let's start by filling the proforma. So we'll first fill in the times of high water and low water for the standard port, because we'll be using those times as a reference time. So we do that, or we obtain those extracts right from here. Alright, so the times as well as the height of high water and low water for standard port is extracted from here. So you can see the high water, this is high water and this is low water in both the cases. So you can see the high water time as 0527 and 1739. The low water times is for 1127 and 2357. As you can see, the times are given here and the height is given in meters. So this M stands for meters. So this is height of tide in meters. So respective to the time, I have also put down the height of tide here, 1.8 and 2 against 0527 and 1739, and minus 0.2 and minus 0.4 against 1127 and 2357. This is taken straight from the Admiralty tide tables extract for a standard port of Davao. Then what we do is we obtain the seasonal change. So the seasonal change, as I showed you above, this is also given in the Admiralty tide tables. This is in the part 2 of the Admiralty tide table. So you can see here, this is also from the Admiralty tide tables. And for seasonal change, it's in the month of October is plus 0.1. Alright, but what happens is when we initially apply the seasonal change, we reverse the sign and make it minus 0.1 in this case. So in this case, the first application, we will reverse the sign and then we'll apply it again later on, as you will see, with the original sign. So because the correction was plus 0.1, I have reversed the sign and made it minus 0.1 in both the cases. So you will apply this correction of minus 0.1 to all the heights above. So then it becomes 1.8 minus 0.1, which gives you 1.7, 2 minus 0.1, which gives you 1.9, minus 0.2 minus 0.1, which gives you minus 0.3, and again minus 0.4 minus 0.1 will give you minus 0.5. So now these are the new heights that we will be taking into consideration for our further calculations. Then comes the time difference. So how do I get the time difference from? So if I go back, and again this time difference is for both high water and low water. So if I go back into the extract section, the first section here, the extract section, this is also from the tide tables. The time differences is given here for mean high water and mean low water. This is for the standard port with reference to the secondary port. So this is for mean high water is 0.128 minus 0.128, and the time difference for low water is minus 0.129. This is the correction we will apply to the times of the standard ports to get the times of the secondary port. Alright, so we'll come back here, and this is what I have done here, 0.128 minus 0.128 and minus 0.129. So these are the corrections I will apply to the standard port times to get the seasonal, so secondary port times of tides. I leave this now here, and I will go into the height difference for interpolation. So this is the part that kind of was not very clear yesterday because I was working with a PowerPoint presentation. I could not show you manually how did I conduct this interpolation. So I'll show you how to conduct this interpolation. So this part here needs you to fill the height difference from interpolation. So let's see how to do that. All right, firstly, to do that we need to first go back into the extracts and use certain values. So the extract will be the first extract here. So you can see the height differences is written here in the extract. This is the height differences. All right, and the height differences is for mean high water spring, high water neaps, low water neaps, and low water springs. Right, now for every standard port there is a value given here. Yes, there are 4 values, and similarly for the secondary port there are 4 values as well. All right, so these are the 4 values. So what I will do is I'll segregate the high water from the low water values. So what I will do is I will go below back into the proforma, and for every high water of 1.6, I will write down the corresponding height difference for the secondary port, that will be 0.3. Similarly for 1 it will be 0.1, for 0.5 it will be plus 0.1, and minus 0.2 it will be 0.4. So this is how I'll write it down first, and then I'll show you how to do the interpolation. Alright, so if I go back here, you can see this is the part of the interpolation. This is where I've shown you the interpolation. So let's start with the high water heights. So for high water heights, as I told you before, I will write down the standard port mean high water values, which is 1.6 and 1, and the height difference for the secondary port values. So against 1.6 it was minus 0.3, and against 1 it was minus 0.1. Now I need for a height of, let's go back and say what height I need it for. I need it for 1.7 and 1.9 meters of high water heights. But the values that I have is for 1.6 and 1 meter. So to get the corrections or to get the height difference for secondary reports for the required height of tides of 1.7 and 1.9 meters, I need to do some interpolation. So let's do the interpolation, because this is the values given to me, 1.6 and 1, again minus 0.3 and minus 0.1. So this shows that for a difference of 1.6 minus 1, which is the difference between these two, 0.6 meters, the height difference for secondary reports, or the difference between the height difference of secondary reports, is minus 0.2. That means it's minus 0.3 minus of minus 0.1, which is minus 0.2. So when there is a difference of 0.6, the height difference is minus 0.2. But I need it for 1.7 meters of height, right? So 1.7 meters of height, when I need it from, it is actually 1.7 minus 1.6 meters. It's only 0.1 meters away from 1.6. Alright, so I have taken the higher value of 1.6. So I need it for 1.7. 1.7 will be somewhere here above 1.6. So that's why I just need it for difference of 0.1. So when there is a difference of 0.6, the height difference is increasing by minus 0.2. So if the height increases to another 0.1, making the height 1.7, what will be the value I need to apply? So therefore, what I will do is I will multiply this by this and this by this. Alright, so here this is unknown, so the unknown will be here. So therefore my unknown value will be equal to 0.1 multiplied by minus 0.2 divided by 0.6. This will be almost equal to 0, if I remember it correctly. So let me do that again. So 0.1 multiplied by minus 0.2 divided by 0.6 is 0. Alright, so I'll just take into the first decimal figure. So this is 0.0. So therefore I'll have no correction. So in this case, for a height of tide of 1.7 meters, my height difference will be same as 1.6, which is minus 0.3, and that's why this is the height difference I have put here as minus 0.3. Alright, let me show you the other example now. So now I need it for a height of 1.9 meters, right? So for a height of 1.9 meters, so again I'll use the same principles. If the difference between 1.6 and 1, so for a difference of 0.6, the height difference is minus 0.2. This is again coming from where? Minus 0.3 to minus 0.1. Yes. So if for a difference of 0.6, the difference or height difference is increasing by minus 0.2, what will be the correction required for 1.9? 1.9 minus 1.6 equals 0.3. So if my height was, instead of 1.7, if I needed it for 1.9, which is going up by 0.3, what will be the correction that I'll have to apply, right? So I will again multiply this by this and bring it here. So in this case, this is my unknown. My unknown correction that I will apply to the height of minus 0.3 will be equal to 0.3 multiplied by minus 0.2 divided by 0.6, which will give me 0.3 multiplied by 0.2 divided by 0.6 is 0.1, right? Now this 0.1, I can see that it is increasing. So as I am going from 1 to 1.6, the value is negatively increasing. So as I will go from 1.6 to 1.9, this value will also negatively increase by how much? It will increase by 0.1, making it 0.4. That's why the correction for 1.9 height will be minus 0.4. Alright, so I'll do the same thing for the low water heights now. Now for the low water heights, interpolation for the low water heights, the standard port mean low water values from the above extract was 0.5 and minus 0.2. Against it was 0.1 and 0.4. Alright, if you don't remember, I'll show it to you again. So these are the values I got from the extract above. This is the extract. This is where I got it from. So for a mean low water neap and mean low water spring, 0.5 and 0. minus 0.2, the height differences was plus 0.1 and plus 0.4. Alright, so this is what was given to us. So we have to use these values here to find the height difference for a required height of tide of 0.3, minus 0.3 and minus 0.5. So these are the corrections we need for. Alright, so let's go back. So for minus 0.3 and 0.5, right? So the first one we needed for is minus 0.3 minus 0.5, right? So we need it for minus 0.3, which will also be somewhere here, and we need it for minus 0.5, which will also be somewhere here. So we have to go down from minus 0.2. So in this case, it's sometimes called extrapolation, not interpolation, because interpolation is for values lying between these, but this is extrapolation, but never mind. All right, so we have to go down from minus 0.2. So now these values are showing us that when there is a difference of minus 0.2 and minus, so going from minus 0.2 going to 0.5 gives us a difference of 0.7. all right, because if you know minus 0.2, if you have to write the numbers, you will write it as minus 0.2 minus 0.1 0 1 2 3 4 5 0.1 0.2 0.3 0.4 0.5, right? So this is a difference of 0.7, right? That's why a difference of from minus 0.2 to 0.5 is 0.7, right? So if for a difference of 0.7, as the numbers go from 0.2 to minus 0.2 to 0.5, the difference of 0.7, the height actually decreases from 0.4 to 0.1. so the height is actually decreasing from 0.4 to 0.1. so there is a decrease of 0.3, so height is decreasing. All right, so therefore if we go down, height should be increasing. So as we'll go down from minus 0.2 to the required heights of minus 0.3 and minus 0.5, height should be increasing, right? So therefore if for a difference of 0.7 is minus 0.3, what will it be for minus 0.1? so this minus 0.1 comes from, this is the difference between minus 0.3 minus of minus 0.2, because this is the required height for which we need. All right, so this becomes unknown. So therefore the interpolation will be, this will go here and this will come here. So 0.3 multiplied by minus 0.1 divided by 0.7. so if you can do that in your calculators as well, you will see it is again 0, so there will be no correction. So as I go down from minus 0.2 to minus 0.3, I can use the same value of 0.4, which you will see I have put here. Alright, because there is no change. Then if I have to go from, similarly if I have to go from minus 0.2 to minus 0.5, what will happen to these height difference values here? This will increase by, or rather decrease by 0.1. so I will show you here, because as we go down the value is decreasing. So what will happen here is 0.3 multiplied by 0.3 multiplied by 0.7, which will give you 0.1. so that means the height will go down by 0.1 from 0.4 as we go down. Right, so once we go from minus 0.2 to minus 0.5, the value will decrease from 0.4 by 0.1, that is equal to 0.3, or rather sorry, it will increase. It will increase because it's decreasing above, so it will increase. My apologies, it will increase because it's decreasing as we go up, but we are going down, right? So it will increase, which will make it 0.5 against minus 0.5. Therefore my correction here is 0.5. so that's how I did the interpolation. All right, so once I did the interpolation, then all I have to do is now apply these height differences. So this will become 1.7 minus 0.3 which will equal to 1.4, and this will become 1.9 from above minus 0.4, which is equal to 1.5. all right, this minus this minus this, and similarly this minus 0.3 plus 0.4 is 0.1, and minus 0.5 plus 0.5 is 0. Alright, so this becomes minus 0.3 plus 0.4 plus 1, and minus 0.5 plus 0.5 becomes 0. Alright, and then we apply the time differences of 1 minus 0128, 0129 to these times here. Alright, so 0128 and 0527 minus 0128 will be 0359. 1739 minus 0128 will be 1611. Similarly, 1127 minus 0129 will be 0958, and 2357 minus 0129 will be 2229. So we get the final secondary port times here, and over here we have got the height, but now we have to compensate for the reverse sign of the seasonal change that we applied before. Remember, the seasonal change was plus 0.1, which we had reversed above and made it negative. We'll make sure that we compensate for it by now applying the sign correctly. So we will apply the sign correctly for October, which is plus 0.1, and we'll apply these 0.1 value plus 0.1 values correctly to each of the heights. So when we apply 0.1 to 1.4, we get 1.5. So this is 1.4 plus 0.1 is 1.5, and 1.5 plus 0.1 is 1.6, and similarly 0.1 plus 0.1 will be 0.2, and 0 plus 0.1 becomes 0.1, and this becomes the final height of tides for the secondary port. So guys, I hope this was a useful video to understand the interpolation process. I'm not sure how effective it was, but watch it with my other video as well. And this video I wanted to focus more on the interpolation, but the other video shows you how I got the extracts and how I fill the proforma, whichever helps you. But I look forward to your feedback and comments regarding this video as well, and I wish you all the best with your studies, and keep subscribing so that you get notification about my further videos. Bye guys.